Okay, now we want to review the properties. All right, so as we're reviewing these properties, all right, can anybody give me an example of the commutative property with letters? Go. You are amazing. Everybody's writing that down. A plus B equals B plus A. All right, the order changes. Does it matter when you add, what order you add things? And the answer is no. 3 plus 2 is the same as 2 plus 3. What else could we say? Instead of addition, we could also do what operation? Multiplication, or we could say AB equals what? BA. Perfect. All right. Now, an example for the associative property. Associative deals with what? Parentheses. Go ahead, give me your example, sorry.
Parentheses A, B, and then the parentheses C, and then is equal to A, and then parentheses B, C.
You are amazing, girl. Good memory. All right. That is the associative property. Notice, is the order exactly the same?
No.
The thing that's different is the what? Parentheses. Associative. All right, who you associate with. That's how I remembered it. The parentheses. All right. Now, of course, instead of multiplication, we could do what? Addition. All right, we could do addition. A plus B, parentheses around that, plus C equals A, and then parentheses around the B plus C. But I think you guys are good enough, especially since this is the second time we've done this worksheet. All right. Now, the additive identity. What do we add and remain the same? 0. So what's the example for additive identity I gave you last year? A plus 0 equals A. That's very good. A plus 0 equals A. Can use a different variable if you would like. Does everybody agree you can use a different variable, right? The variable does not matter. And here I wrote property and I forgot to fix it. What did I mean to write here? Identity. Nope, not yet. We're getting there. Change that to an identity, please. I got to fix that. Multiplicative identity. So what was the multiplicative identity? What do I do? What do I multiply to remain the same? 1, right? So what am I going to do for that, Peter? Give me an example. Yes, sir. A times 1 equals A. Now remember, identities remain the same. Inverses cancel out. All right, so what would be an example of the additive inverse? Additive inverse, where things cancel out. Come on, give it a shot. Someone else be brave. All right, Suri, tell him.
Wait. -1 plus 1.
Yes, -1 plus 1 would be an example of the inverse. All right, but let's use variables. So it's a little bit trickier when we're using variables. So we're going to use what? X plus what? -x. All right, that's just saying when they're opposites, they cancel out. That's what the additive inverse is. But she was absolutely correct. -5 plus 5 is 0. All right. Now that you've seen the additive inverse, you should be able to talk to me about the multiplicative inverse. What was that?
That would be x times -x.
Not quite. That would be x. Go. Nope, that would be the 0 property. How do I cancel out multiplication? Nope. Tell us. No, not adding. Not adding. Yes, divide A by A, but instead of saying divided by, it's going to be called A times the reciprocal 1 over A. Those cancel out to become 1. So that is the multiplicative inverse. That's the multiplicative inverse. All right, now let's do an example of the distributed property. So I'm going to go ahead and just write out A parentheses B plus C. And that would be, who remembers? What are you thinking?
So wait, for the distributed.
I want you to distribute the A. What would I get?
So you'd times A times B and then you'd times it by C.
That's right. AB plus AC. That's your example of the distributed property. You distribute the A to the B and you distribute the A to the Z or to the C. Okay, someone help me with the zero property. What was the zero property? Aiden? Yes, there you go. Anything times zero is what? Anything times zero is zero. All right, so you definitely need to know that. All right, now hopefully you kind of remember that from last year. All right, we even did a little bit in 6th grade. All right, now the set of numbers. All right, and natural numbers, does anybody remember we abbreviated that with what letter? N. And the natural numbers, we're going to call, do you remember what those numbers were? Sorry? Yes, ma'am. Very good. 1, 2, 3, ... Positive counting numbers. Positive counting numbers. So whole numbers. Yes, good job, girl. And we label that as a what? W, and we call it 0, 1, 2, ... All right. What's the only difference between a natural number and a whole number?
It's a 0.
0. That's it. All right. Now, does anybody remember integers? What was the abbreviation for integers? Do you remember? You are right, girl. That was really good. Z. All right. I have no idea. They couldn't call it I because there's a set in Algebra 2 you will learn. It's called imaginary numbers. That's correct. So Z is referred to as integers. So those are just what? Yes, good job. Those are the counting numbers, right? All counting numbers, positives and negatives. All right, so generally they say the counting numbers and their opposites. So that's a set of integers. Okay, now does anybody remember what rational, what I told you for rational? There's a fraction, right? And we remember that because ratio is the root word, ratio. All right. And what letter do we use for rational? As you remember? Q. Very good. Very good. Q was the letter we used. All right. Now, rational, I just want you to write down as any number that can be written as a fraction. Any number that can be written as a fraction. All right. That's the definition of rational. So then you just drop down. So if rational is a number that can be written as a fraction, then irrational means any number that cannot be written as a fraction. All right, those are the definitions. But most importantly are the examples. All right. So let's do some examples for rational numbers. Is 0.3 repeating? Can that be written as a rational number? Yeah, it's 3/9. We talked about that. So yes, repeated decimals can be written as fractions. What about, for example, 0.51? Can that be written as a fraction? Yeah, 51/100. So decimals are now included in the picture. All right. Decimals are included in the picture. So any number that can be written as a fraction. Is a natural number a rational number? Yes, because they can all put a 1 underneath it. So if you are a natural number, then you are a whole number, then you are an integer, then you are rational. Does everybody agree with that? All right. If you're rational, does that make you an integer? No. Going backwards does not work. But going down, it does work. All right. Now, what are examples of irrational numbers? Pi, thank you very much. All right, and you will learn in calculus how to determine the numbers 3.1419567. All right, they will teach you how they came up with all those numbers. It's really fascinating. All right, does anybody else know what irrational could be? You are amazing, girl. Square root of what specifically? A non-perfect square. That's perfect. So if I said the square root of 3, that's irrational. Square root of 20, that would be irrational. But the square root of 25 would be considered rational because the square root of 25 is 5. 5 can be written as 5/1. All right. Right now, real numbers are what? All numbers. All right. This is the symbol for real numbers. All right. It's just a line, and then make an R. That's the symbol for all real numbers.
What is it for irrational?
Irrational, believe it or not, it's just IR. And real numbers right now are all numbers. Right. But like I said, when you get to Algebra 2, they will teach you about what? Imaginary. All right, they will teach you about imaginaries. All right, so hopefully that wasn't that bad for you guys. All right, let's scroll down to the page. Now, let's just flip back and forth. If you don't know, it's because you haven't looked. All right, so number 1, let's just start up here. Sadie, let's just go around the room now. All right, please pay attention so we can get done. All right, we're just going right down the row. Sadie, what are you thinking for number 1? Yep, so we can say COMM dot and it's addition. If you're going to abbreviate, that's how I want you to abbreviate. Surrey, number 2. Right, be careful how you abbreviate associative. All right, associative of multiplication. Good. Sunshine, what do we got for number 3?
Okay.
What multiplicative? Well, I know there's something else you left out.
Oh,
Yes. Yes. Multiplicative identity. Number 4. What are you thinking? Yes. Additive what? That's correct. Additive identity. All right. Palmer, you're up.
Is it the additive inverse?
You are amazing. Additive inverse. Next. Me, yes. Miss Lupin, go. What's number 6? You are amazing, girl. Multiplicative inverse is correct. All right. Next. That's correct. Distributive property. Next.
Distributed.
You are amazing. Next. Bolton.
That would be multiplicative inverse.
That is correct. Multiplicative inverse. Bruin.
Um, this,
Uh-huh.
this-
Additive. No. You're adding 0. Look up on your notes. Which one is adding 0? Don't anybody tell him. Yes, that's all there is to it. All right, you have to just look them up if you don't know it. Hopefully there's some logic here. Next, Liv. Commutative property of addition, beautiful. Next.
associative, no,
Multiplication, yes, multiplication, that's it. 13, go. Yes, additive inverse. Next. Nope, definitely not. Always look at the order. Are things canceling? So I see parentheses in the wrong spot. So which one deals with parentheses? Yes. All right, associative property of addition. Do you agree with that now? All right, does everybody realize you're just looking up the property? All right, that's all you're trying to do. All right, next.
Is it multiplicative order?
You are amazing. Multiplicative inverse is good. Next. Yes, I tried to trick you on this, so be careful. What is it? Nope, it's definitely not distributive. Always look at the order. Read the order to me. Yes, very good. Because the X and Y are out of order. X and Y are out of order, so it's automatically commutative property of addition. Very good. Next. Aiden, go ahead. The zero property, exactly. And number 18. Mr. Wash. You are amazing. Additive inverse. All right, let's go back up here. What are you thinking? Sadie, you're right. Start with the right side. What did we do to the two? There you go. Distributive property. Sorry, what's next?
Associative.
That's correct. Okay, here we go, sunshine. 5 is what?
Natural, whole, integer, rational, and real.
You are amazing. Are all of them real? So if you want to save yourself some time, you can just go check them all off for reals. Okay, next. -9 is a what? Amaya. I like integer and rational. But remember, only whole numbers are positive, kiddo.
Oh.
You with me on that, right? So make yourself a little note if you forgot something as you're going. All right, that's why there's lots of practice here. All right, -3.5. Palmer, you're up.
3.5.
Is what?
I think it's. Okay. It's not natural or whole. I think it's not. I think it's rational.
You're right.
and
It's
real.
rational and real. Thank you very much. Next, 24 pi. It is just irrational and real, of course. Good job. Number 25. Rational and real. Thank you very much. Katie.
Rational.
Square root. It's not a perfect square. Irrational, right? If it was 9, you would say different. You hear me?
Yeah.
All right, so that's irrational. Colton, what about 4 9/11s?
That would be rational.
That would be rational and real. All right, here's the one. Greep, square root of 25. What does the square root of 25 equal? Yes, it does. All right, so it's definitely rational. What else? Natural, whole. Yes, integer. That's it. Everything but irrational. Very good. Now, Liv, I tried to show you that there was no pattern to this. So 9.1754021 just repeats without a pattern. So what is that? Irrational. Thank you very much. That is definitely irrational. Leah, what about -32, kiddo?
Integer, rational and real.
You are amazing. 0, whole. Amazing. Next. Screen. It is definitely rational. Thank you very much. All right. Luke, what are we at? It's definitely an integer. It's definitely rational. First of all, look at your notes. What does natural say? Is it part of the natural? Well, the ... means it goes on. That's your mistake. You with me now? That ... means it goes on and on and on. So is it natural? Is it whole? What does the whole say? Yes, those dots mean it goes on. You with me? All right. And 27 thirds, Peter, what is that?
Thirds,
Uh-huh.
that's real, that's rational, whole, that's natural, it's 9.
That's correct. That's what I wanted you to say. That's the same as 9. All right, so everything applies. Everybody good with that? And then I just have what here? Extra practice, guys. That's your homework. All right, that's your homework. It's not going to take you long, right? Listen, if for some strange reason you get done a little bit early, you got to find something else to do, guys. I can give us more work, but it's not necessary. All right, so get to work, finish it up. All right, then tomorrow I will just collect it. All right, I'll just look at your iPads. No, you don't need to turn it in. All right, I don't want to go through all that. I'm just going to walk around the room and say, show me. Great work today.